the next function that I created is the rebar suggestion function. The aim of this function is to output a data frame consisting of suggested reinforcements. A data frame is a group of data arranged in a tabular format. I started by initializing a list of commonly used rebar sizes for beams like T20, T25, T28, and T32. And then I initialized an empty list of its corresponding quantities for the bottom bars. I also initialized an empty list of the number of layers for the bottom bars arrangement. I also included an initialized empty list for top bars and its corresponding quantities. Then I used a for loop to make an iteration for each rebar size on the list. So for each rebar size, the code will compute the rebar cross-sectional area using the formula pi d squared over 4. So I imported math module to use the math.py function. It then calculates the maximum steel ratio or the rho max given by this formula. And then to calculate for the effective depth, I assume the rebars are arranged in one layer since I don't know yet the quantity of the bottom reinforcement. So using rho max, I then calculated the maximum steel area using the formula rho times B times T effective. I used rho max because it is the maximum permissible steel area specified by ACI code. From here, I can determine the number of rebars by dividing the maximum steel area by the rebar cross-sectional area. And I use the math function math.ceil to round off the quantity to the next integer. So if it gives a value of 3.2, for example, then it will round off to 4 numbers of rebar. Finally, I append these quantities to the initialized list. So now that I know the number of rebars, I can check how many layers the bar should be arranged such that there is no congestion. For this, I created a generator to solve the number of layers. A generator is basically a for loop written in a single line. This generator will try to check if the quantity of rebars can't fit in one layer. Due to inadequate spacing, it will try to fit the rebars in 2 layers, or 3 until an adequate spacing is achieved, or until the spacing between the rebars is greater than the diameter of the rebar as a minimum requirement. The next function on the generator will extract the first number of layers that satisfies the spacing condition. I then append the number of layers onto the initialized list. For the top reinforcement, the diameter will follow the same size as the bottom reinforcement, and the number of top reinforcement will be minimum 2 numbers and maximum 3 numbers as defined by these if-else statements. I then append the top bar sizes and the quantities to the initialized lists. But then again, the user has the option to increase or provide his or her preferred reinforcement. This function is only trying to suggest few possible reinforcements that can be used, so the user has something to start with. Now that all the lists are complete, I created a dictionary to store all these lists. A dictionary in Python is like a storage of data wherein I can map using the keys as the label with its corresponding values. I then imported pandas module so that I can make use of the pandas data frame function to convert the dictionary into a data frame so that I can display it in a tabular format. So this function returns a data frame. The main code starts with printing out the title and getting the user input. It first asks the user to input the values of concrete strength, the steel strength, and the size of the beam. Then it prints out that the code assumes a value of 40 mm for the concrete cover and a tie diameter or stirrups diameter of 10 mm. I use a while loop with try, except, and else method so that it will only accept an input which is a float object, meaning the input must be a number, a whole number, or a decimal number. If the user inputs a string like letters or punctuations or symbols, then the code will raise a value error and it will print out data input error. Since it's in a while loop, the code will keep on asking the user until the code gets a float value. Else, if all inputs are float, then the code will proceed. I start by assigning the constant values. ES is the steel modulus equal to 200,000 megapascals. EC is the maximum strain in concrete, which is equal to 0.003. EY is the strain in steel at yield point and can be calculated directly by using the steel strength divided by the steel modulus. CC is the concrete cover, which is fixed to 40 mm, and tie is the stirrups diameter, which is fixed to 10 mm. Then I call the function beta1 underscore value, which calculates the value of beta1. I created this function earlier. I also called the function Rebar suggestion, which outputs a data frame or a table containing suggested reinforcements with corresponding quantities. So for every reinforcements on this table, the code will calculate the corresponding moment capacity and will classify the beam if it's in tension or it's under compression control or under transition. It will also evaluate if the steel ratio is within the limits specified by ACI code. Afterwards, the code will display the table with all the calculated data. In order to do this, I first initialized empty list for moment capacity, classification, and steel ratio. Then I make an iteration for I in range from 0 to the length of the data frame index to unpack the values. In other words, from the first row to the last row of the table, it will extract the values of the reinforcements and its quantities, and then use these values to calculate for the steel areas, the effective depth, the depth of the top bar, the tensile stresses and strain values, the strength reduction factor, and the classification, and finally the forces and ultimate moment capacities. All these functions I have predefined earlier. After the code has executed these functions, it will append the values of the ultimate moment capacity to the initialized list. It will also append the classification and the steel ratio, which is under this function. Then I added this list onto the data frame by passing new column labels for capacity, classification, and steel ratio with its corresponding values. The code will then print suggested reinforcements and then will display the updated table or the data frame. I inserted a command that tells the code to delay for 1 second before it pops out the data frame. I imported the time module so I can use the time.sleep function. The next part of the code is allowing the users to input their preferred reinforcements. The code will ask the user, would you like to provide reinforcements to check? Then the user can answer Y in small letter, or if the answer is in capital letter Y, the code will convert it to lowercase and will evaluate as long as it starts with Y. So the user can actually input the word yes, or Yahoo, or YOLO, any word that starts with Y, and will ask the user to proceed to input the reinforcements. I used a while loop again so that the code will only accept integers or whole numbers as inputs. Because the rebar sizes and quantities should be in whole numbers, it will raise a value error if the input is not an integer. I also added Another condition that rebar sizes must be greater than 10 mm diameter, and the minimum quantity should be two numbers for practicality. So if the user inputs one number of 8 mm diameter bar, it will raise an error and will keep on looping, and it will keep on asking until it gets the correct input. Else, if all inputs are correct, then it will proceed to calculate, and it will use the same set of functions that I predefined earlier to compute the moment capacity, the classification, and the steel ratio. Then it will print out the rounded off value of the beam capacity, and it will also say what classification the beam is, and it will also say if the steel ratio is within limits. Then it will exit the program. I use the F after the print command so that I can concatenate or join the strings together with the values in curly brackets under one quote. The \n is basically telling the code to display a new line. The last else command on the code will execute should the user answers no to the question, would you like to provide reinforcements to check? If the user answers anything that doesn't start with Y, then this command will execute by printing, have a good day, and then the code will execute.